Hello, in this video I'm going to go over how we can make some sounds on the NES using its APU chip, which stands for the Audio Processor Unit. So there's two different versions of the APU which are dependent on which machine you have. If you have an NTSC machine, which is for the American region, then you would have RP2A03. That's also for Japan as well, and then the rest of the world, Europe, would have the PAL version. So there's 5 channels, there's 2 pulse wave generators. So I've got in brackets there square, and that's because the waveforms themselves are kind of square if you were to view them, but because we can change the width of the waves, it's considered to be pulse. And then there's a one triangle wave and one noise generator, I suppose you would call it. And then there's the DMC channel, which I won't be going into here, which can play DPCM samples. I haven't gone into any detail on this because I'm not totally sure what they are. It's obviously some format for playing, as it says, sample waveforms. Lots of games at the time didn't use this because obviously if you're going to create sound samples, then it uses a lot of memory. So the main registers for the APU are between 4000 and 4015, and then there's also 4017, which is an additional register. So these numbers here are in hexadecimal, by the way. So the main channels, there's 2 pulse channels, a triangle and a noise channel. The pulse wave generators have 4 registers each. So the first pulse wave channel has 4 registers between 4000 and 4003. The second 4004 to 4007. And then the triangle wave between 4008 and 4000 in B. Noise is 4000 in C to 4000 in F. All of the details that I'm given here are from the nesdev.org wiki about the APU. So how do we even use the APU? So to start off with, we would first send the value of 15, which is 0F in hexadecimal, to 4015, which is the enabling register, and they also referred to as the status register, as it's read and write, which is not the same as most of the other channels. Lots of the other channels are write only. So the reason why it's called status is because you can read the registers from here as it's in action to get an indication of what the channels are actually doing. And then the second part we need to enable the channels is to send a value of 64 to register 4017, which disables the IRQ interrupt being set. And then once we've done that, we then need to send bytes to the individual channels which we wish to work with. So now what I will do is to kind of stop me from reading off of various info. I will now show a program I've wrote to make this all a lot easier. So this program here allows us to play around with the settings of each wave channel. So this is the pulse channel 1, and then these are actually bytes, but this is split into bits, which makes it easy for us to understand what we're actually setting here. So each bit in the registers, so this is channel 1 here, so this is register 4000 here, this is 4001, 4002 and 4003. So I could have read off of the various stuff online, but it's easier if we play around and I kind of show you things. So first off, to get a sound out of it, we're going to set the volume. So if we don't have either of these two flags here set, so this is this flag here, L, is an envelope loop. If set, if cleared, it's a length counter halt apparently. And then the C flag here is either volume or envelope. So the easiest way to sort of get working with these things is just to set them and then see how we go here. So this register here is mainly to do with setting up the volume, and then we can play around with these and create like a kind of a volume envelope effect. The 2D registers here, these change the duty of the pulse wave, which is the how much of that sound is actually fluctuates between on and off, which will give us different sounds out of the wave channel when it's actually working. This byte here is purely to do with sound sweeping, which is the changing of the frequency of the note or the sound as it's actually being played over time. So first off, I won't touch that. And then what we've got here is, so these are the low byte of the sound, and these three are the high byte of the sound. So the value can be between 0 and 1023 for the NES. And then these 5 bits here control the length of the sound. So if we go ahead and set some of these up, so that's how we can get a sound out. So that demonstrates the different duty bits here to change the sound over it. Now if we put this one on and do it, so that's the loop sound. So the constant one here, that will play so that you can hear the changes with the volume here. So now let's play around with the sweep register here. Now to enable the sweep register, we have to set bit 7 to 1, and then this flag here, N, that decides which direction the sweeps will go in. So it controls whether the sweeps are up or down. So if it is set, I'm not sure whether this is a negative. I think this is the negative sweep. So this changes the direction of the sweeps here. So you can use channel 1 and channel 2 pretty much. Both of the two pulse wave generators are very similar, so you could use one for sound effects or music, I suppose, or both, depending on what you want to do. So I won't bother going over any more of these here. Definitely check out the NES Dev wiki if you're more curious to what each of these bits actually do here. I just want to so these are the amount of sweeps using the sweep register, so they can be between 0 and 7. And then these here, these P flags are for period. I think that just deals with the shifting as well. And then the key bits here is all these changes you make here. These 4 bytes at the bottom can be used to then reproduce that sound by plugging them back in to register 4000, 4001, 2 and 3. So the sound won't start until you put the last byte in here. Then you'll get whatever you've got here. So it's useful for creating sound effects for games. So the keys, if you like, for this are, so the D-pad to move around, and then the A button to change a flag. B does nothing. Select will take us through the 4 channels, and then start will play the sound. So this is the triangle channel here. So this one is this one only has 3 registers associated with it, although the range is from 4008 to 4000 in B. Only 3 of the channels in that range are actually used. So this is a weird one. So we've got the constant flag here at the end, and then these affect the timing or the length of the note, as well as the length of the note at the bottom here as well. And then the L and H parts are for the actual sound tone, again between 0 and 1023. So the sounds here are 1 octave lower than on the pulse channels. So let's make a sound here. So you notice that there's no sort of way to control the volume on the triangle. It's literally just these. If you put this to 1 and then play the sound, it will be constantly on. So you have to write all of these each time to the registers. So this first register here is 4008, that's 4000 in A, and this one is 4000 in B. So now let's go to the noise channel here. So again, this has three registers associated with it, and these are 4000 in C, 4000 in E, and 4000 in F. You'll see here that not all of the flags or the bits are actually used in the generation of this here. So we've got a loop bit here, and then a constant bit again, and the volume or length bits. I just treat these as volume really, so let's smash the volume in there. And then this is set up slightly differently here. So we've got like a loop bit here, and then the noise period, and then a time at the bottom here. So you can use this for creating various explosion gunshots and that sort of thing. Now, having the constant on here, if you if the range of the sound goes outside of the set parameters, then it will switch off. So if you wanted a sound to be on for longer than the length of these bits state, then you could literally just have the loop flag set and then hand over timing of it yourself to have it go on for longer. So again, plug these in to reproduce that sound. That's pretty much all I want to cover in this video, so I will post a link for the ROM for my SoundMaker program for you to use in your programs. And in my next video I will show you how you can plug in these bytes for the sounds that you've made, and also how to play some music as well. So that's it for this video.